life, every day, late at night, not okay. All I want, and I pray, all I need are some better days.
Django pagination versus Wagtail pagination. Django versus Wagtail pagination comparison. Let's start with Django pagination. Django's built-in pagination is a versatile solution, suitable for various types of data in Django applications. Django's built-in pagination is a versatile tool that can be employed to paginate a diverse array of data types, making it a valuable asset for developers working on a wide range of Django applications. It can be used to paginate any query set. The ability to use Django's pagination with any query set makes it an incredibly versatile tool for managing and presenting data in your Django applications. Whether you're building a blog, an e-commerce platform, a social network, or any other type of web application, Django's pagination provides a consistent and flexible way to handle paginated data, regardless of its source or complexity. Django's Paginator class allows developers to manually implement pagination with fine-grained control over pagination logic and appearance. Django's Paginator class provides developers with a powerful set of tools to implement pagination in a way that aligns precisely with their application's requirements. This fine-grained control extends from the underlying data handling to the user interface, allowing for a tailored and user-friendly experience while maintaining the application's unique look and functionality. Next, let's dive into the world of Wagtail pagination. Wagtail offers its pagination system primarily designed for content managed within the Wagtail CMS. In other words, Wagtail's pagination is optimized for use within the Wagtail CMS environment and is well suited for handling content like articles, images, pages, and other types of data that are organized and managed using Wagtail's content management. It may not be as versatile as generic pagination solutions, but is tailored to seamlessly integrate with Wagtail's content structure and workflows. This pagination is automatic and seamlessly integrated with the Wagtail CMS, requiring minimal setup. In essence, Wagtail's pagination system is designed to make pagination a hassle-free and integrated part of content management within the CMS, ensuring a smooth user experience for both developers and content editors. In summary, consider your project's context and whether it primarily involves content management within Wagtail or requires pagination for various data types. Your choice between Django and Wagtail pagination should align with your specific use case and development requirements. Let's now proceed to open our views.py file and begin implementing pagination within our listing views. I've opted to utilize Django pagination over Wagtail pagination for this specific project, as we are developing an online news magazine that incorporates both Django and Wagtail. Our prior experience has shown that Django pagination proves to be a versatile an effective tool for this scenario. We commence by importing the Paginator module from Django.core.pagination. Under the hood, all methods of pagination use the Paginator class. It does all the heavy lifting of actually splitting a query set into page objects. Before we proceed, let's illustrate the usage of Django's Paginator to organize a list of objects into pages and obtain pagination-related details, including page count, object contents per page, and the presence of next or previous pages. To do this, we'll utilize the Django shell. Feel free to open it by running python manage.py shell. Here, we're importing the Paginator class from Django's pagination module. Then create a list called objects containing some names. And we initialize a Paginator object P with objects and specify that there should be 2 objects per page. The numPages attribute of the Paginator object P provides the total count of pages required to present all the objects, while adhering to the designated page size. In this specific scenario, the page size is set to 2, meaning that each page can accommodate up to 2 items. So, if each page is designed to hold 2 items, and we have a total of 4 items in our objects list, then we will need a total of 2 pages to accommodate all of these items. The page range attribute of the Paginator object P provides a range that represents the valid page numbers available for navigation. Here, we are getting the first page of the Paginator object P and storing it in page 1. This output indicates that page 1 is an instance of a page in the Paginator, and it is currently displaying the first page out of a total of 2 pages. It's a way of representing and accessing a specific page of your paginated content. Page.object_list returns the objects that belong to the first page, which are John and Paul. Now, we are getting the second page of the Paginator object P and storing it in page 2. Page to dot as previous is a check to see if there exists a page before the current page, which is page 2 in this case. Since there is indeed a page before page 2, which is the first page, it returns true. Page 2 dot has next is a check to see if there is another page immediately following the current page, which is page 2. It returns false because there is no third page available after page 2. In other words, you've reached the last available page, so there's no next page to move to. That was a concise overview of the Django pagination feature that we will be employing in this web application we are developing. This demonstration covers the essential aspects that we will utilize extensively, both in our listing views and within our HTML templates. Now, let's kick it up a notch and dive into integrating this slick pagination feature into our list views. We're defining a variable named post per page and setting it to 3. This variable represents the number of posts we want to display on each page of our web application. So, on each page, we'll show a maximum of 3 posts. Here, we're creating a Paginator object named Paginator. This object is provided by Django and allows us to organize our list of posts into multiple pages based on the specified post per page value. This is the list of all the posts we want to paginate. It contains all the posts that we want to display in our web application, and we will add it as the first argument. In our Paginator constructor, we also pass the post per page variable as the second argument to the Paginator constructor. This tells Django that we want to display 3 posts per page. We retrieve the page parameter from the URL, which is often provided by users when they click on page navigation links. This way, you can dynamically determine which page of content the user wants to access and display the appropriate posts accordingly in your web application. This variable will hold the page of content that you want to display to the user. It's a common practice to name it PageObj for clarity, but you can choose any variable name you prefer. Now, let's incorporate the PageObj into our context variables to make it readily accessible within our template. Now, let's integrate this element into our pagination template, which we've previously set up. This step is crucial to ensure that our pagination mechanism is seamlessly incorporated into our web application's user interface. In this span element, we add the current page number and the total number of pages. This gives users context about their current position within the paginated content. Then we use a conditional statement to check if there is a previous page before the current one. If PageObj has a previous page, the following links will be displayed. These links allow users to navigate to the first page and the previous page, respectively, if they exist. We've used the page equals query parameter to specify the page number in the URL. We initiate a loop that iterates through the available page numbers within the paginator's page range. Inside the loop, we check if the current page number matches the iterated page number. If they match, we display the page number as a non-clickable span with the class current, indicating the current page. If the current page number doesn't match the iterated page number, we display it as a clickable link. Users can click on these links to navigate to specific pages. Similar to the check for a previous page, we used a conditional statement to determine if there is a next page. If so, the following links will be displayed. Now, let's navigate to the index.html file. Instead of iterating through the posts objects directly, we will loop through the page object that we previously passed within our context. This adjustment will seamlessly integrate our paginated content into the template. And, as a crucial step, ensure that you've included the pagination template in our index.html file. This inclusion will ensure that our pagination controls are seamlessly integrated into the overall layout of our web page. Now, for the moment of truth. If your server is still up and running, let's fire up your browser and witness the dazzling transformation of our paginator. If it's not currently running, let's get it up and running now to experience the magic in action. Oops, it appears a small hiccup slipped in, but not to worry. It's a minor blip in the grand scheme of things. Let's swiftly correct it, no biggie.